Okay, in this video we're going to look at how can you tell whether an equation is going to have one solution, whether it's going to have infinitely many solutions, or if it's going to have no solutions. So in this first exercise we have three equations, and I would just like you to take a minute or two and solve each of them. Pause the video and then resume after you finish solving them. Okay, so I'm assuming that you tried to solve these on your own, and now I'm just going to go through what each of them would have looked like. For this first equation, I'm going to use the property of equality, which says I'm going to subtract 5x to start. Okay, on the right-hand side is where I make my 0, and I'm left with just the 5. On the left-hand side, I will have 7x minus 5x, which is 2x, minus 3. Then I'm going to use the addition property. I'm going to add 3 to make my 0. And this will be 2x equals 8. And then by inspection, I can say, well, this is x equals 4. Okay, on the second equation, I'm going to start with the subtraction property, and I'm going to subtract 7x on both sides. When I do this, interestingly enough, on the left-hand side, I have a 0, but also on the right-hand side, I get a 0. And I'm left with negative 3 equals 5. So that's interesting, and we're going to talk about that in the discussion questions that follow. And then for the third equation, again I'm going to subtract 7x on both sides. And this will leave me with, well, I get two zeros again, negative 3 equals negative 3. So our first discussion question is, was there anything unusual about solving equation 1? And I would say no. Right? We solved it as we normally would, and we got x equals the number 4. So this would be no. We solved like usual and got x equals a number. That's what normally happens. And then it's asking, what can you say about the coefficients and constants in the expression from equation 1? Well, the coefficients are the numbers in front of the variables. So I see a coefficient of 7, and I see a coefficient of 5, and I would say they're different. So I would say the coefficients are different. And the constants are negative 3 and 5. And likewise, the constants are also different. So I'm just going to write what they were. The coefficients were 7 versus 5, and the constants were negative 3 versus 5. Right, the next question is saying, suppose the constants in both expressions happen to be the same. Would this change the type of solution you would expect? What would the solution be? So now I've taken the equation and I made the constants negative 3 in the first equation, and I made the constants 5 in the second equation. Is this going to change our answer in any meaningful way? Well, let's solve it like we did in the first one. I'm going to start by, again, subtracting 5x. There's my 0. 2x minus 3. And this is going to equal negative 3. Now I'm going to add 3. I get 2x equals 0. Well, anything by inspection tells me that anything times a number that would give me 0 has to be 0. So this tells me that x has to be 0. And how about this other equation with constants both being 5? Subtract 5x. There's my 0. 2x plus 5 equals 5. Subtract 5. I get 2x equals 0. So again, my answer, 2 times what number is equal to 0? Well, the only number that would work is 0. So interestingly, if the constants are the same, right, it's going to change your solution to be 0 all the time. So if the constants are the same, okay, but again, it's important to know that the coefficients were different, right? So if the constants are the same, coefficients different, we're going to get 0 as our solution. Okay. So now is when it gets a little bit interesting. Equations 2 and 3, certainly something weird did happen. And what happened was our variable term went to 0, right? And we were left with either a false number sentence, as in this one, equation 2, or we were left with a true number sentence, as in equation 3. So for this one, D, was there anything unusual about solving equations 2 and 3? We're going to say yes. The variable term made a 0. So how do we interpret this? How should we interpret negative 3 equals 5? And how should we interpret negative 3 equals negative 3? Well, in the case of the false number sentence, we're going to say that means there is no solution. Right? And all that means is no matter what number you pick for x, the left-hand side expression will never be the same as the right-hand expression. And for a true number sentence, we're going to say that means infinitely many solutions, or all real numbers. Right? Infinitely many solutions just means there's an infinite amount of solutions. All real numbers means any number you choose would work. Okay, so how does this relate back to coefficients and constants? Well, let's look at our equation. In equation 2, we had the same coefficients, and in equation 3, we also had the same coefficients, but what was different was the constants. If the constants are different, as they are in equation 2, we're always going to get a false number sentence. And if the constants are the same, we're always going to get a true number sentence. So that result is summarized at the bottom here. So when looking to classify the number of solutions to an already simplified equation, so what's important to know is that each equation we looked at, the expressions were already simplified. So sometimes you might have to do that first. If the coefficients are different, you're automatically guaranteed one solution, and it's going to be 0 if the constants are the same. And then if the coefficients are the same and the constants are different, you're going to have no solution. And if the coefficients are the same and the constants are the same, you're going to have all real numbers, which is also going to mean you're going to have infinitely many solutions. All right, so this video is on how to tell if you're going to have one solution, no solutions, or all real numbers as your solution for an already simplified equation.